Okay, so this is a review for the quiz that we have coming up this week. Write an inequality that represents each of the following graphs. So that you need to remember your open circles and your closed circles. So number 1 has a closed circle on 2, and everything is shaded to the left of that. So that basically means that x can be any value that is less than or equal to 2. The second graph has the entire graph shaded with the exception of a positive 1. So x can be anything that it wants to be. It just can't be, is not equal to 1. Third graph, open circle on -1, everything shaded to the right, which means x can be anything that's more than -1. It's not a closed circle. -1 is not part of the solution. Number 4, it's a closed circle on -1 and everything to the right. So x can be anything greater than or equal to 1. Sorry, -1. Sorry about that. Okay. Which number is in the solution set of 5x plus 3 is greater than 38? You need to be able to solve this thing to figure it out. So essentially, I'm going to subtract 3 on both sides, and I'm going to get 5x is greater than 35. I'm going to divide both sides by 5, and x has to be greater than 7. Well, now I'm going to test all my choices. Is 5 greater than 7? No. Is 6 greater than 7? No. Is 7 greater than 7? No. Is 8 greater than 7? Yes. 8 is the only value in the solution set. Remember, 7 is not more than 7. 7 is equal to 7. Be careful. Next one. What is the value of x in the inequality? 3x plus 2 is less than or equal to 14. So I'm going to actually bring that down here. So 3x plus 2, I'm going to subtract both sides by 2 and get 3x is less than or equal to 12. Going to divide both sides by 3 and get x is less than or equal to positive 4. Well, if I look at my answer choices, I can see that the first two choices have a -4, so those are out. Well, the answer choices are not written with the variable on the left-hand side. So let's see if I can figure this out. If x is less than or equal to 4, then 4 must be greater than or equal to x. Understand that I have not reversed the inequality symbol. I'm trying to get this is not, there you go. There, if I get the highlighter. Okay, so the fact that my inequality symbol is open to that positive 4, it's still open to that positive 4. I did not reverse the symbol. I just rewrote the solution. So now, when I rewrite it, 4 is greater than or equal to x, and the choice is 3. Solve and graph. That's what's coming up next. Solve and graph. So on the first one, I'm going to bring the variables to the right. So I'm going to subtract both sides by 2x. And I'm going to end up with 8 less than or equal to 4x minus 20. If the variable goes to the right, without the variable goes to the left. Add 20 to both sides. 28 less than or equal to 4x. Divide both sides by 4. I'm not dividing by a negative. I don't need to reverse any symbol. You're going to end up here with 7 is less than or equal to x. Understanding if 7 is less than or equal to x, I can rewrite it and say x is more than or equal to 7. I didn't reverse any symbols. I just rewrote the inequality. 7 is in the middle, 8's on the right, 6 is on the left. I've got a greater than or equal to piece, closed circle, error goes to the right. Next one, distribute. This becomes negative 8x plus 24, right? Distribute, distribute, less than x plus 6. I'm going to bring the variables to the left. I'm going to subtract x. Remember, you can bring them to any side you want. This becomes negative 9x plus 24 is less than 6. If the variables went to the left, without variables have to go right. I'm going to subtract 24 on both sides, and I'm going to get negative 9x is less than negative 18. I'm going to divide both sides by a negative 9. That should be enough to make you slow down and said, wait a second, if I'm dividing by a negative, I have to reverse the inequality symbol. Less than turns into greater than, x is greater than positive 2. When I set this thing up to graph, I've got 2, 3, 1 in the right order. There is no equal to component, so it's an open circle, and all the numbers to the right are greater than 2. Next one. Some distributive property has to happen. So I get distribute 4 minus 12x minus 14 is greater than 8x plus 12 minus 9x. On the left-hand side, I have some like terms. I've got 4 minus 14, or negative 10 minus 12x greater than. I've got 8x minus 9x on the same side, or negative 1x plus 12. I'm going to bring the x's to the right this time. I'm going to add 12x to both sides. Negative 10 is greater than 11x plus 12. I'm going to subtract 12 now on both sides, and I'm going to end up with negative 22 is greater than 11x. I'm going to divide both sides by 11. I did not divide by a negative. I do not reverse an equality symbol. The variable stays on the right-hand side. I've got that symbol and negative 2. So if I read it from left to right, negative 2 is greater than x. If I read it from right to left, it's x is less than negative 2. That's what I'm graphing. X is less than negative 2. Here's negative 2. To the right is negative 1. To the left is negative 3. You better set your number lines up correctly. It's an open circle. Where are you less than? Negative 2 to the left of negative 2. Let's try this next one. Let's distribute here. And we're going to get, let me just kind of draw a little line in here. So distribute, we get 6x minus 3 greater than or equal to 3x plus 1/2. I like to get rid of my fractions. My denominator is a 2. I'm going to multiply the entire equation by 2. It's doing that math, but I'm going to do a little bit faster this time. So 2 divided by 1, because that's what the denominator of 6 is, times 6x is 12x, minus 2 divided by 1 times 3, minus 6, greater than equal to. 2 divided by 1 is 2, times 3x is 6x, and then 2 divided by 2 times 1 is just 1. I'm going to bring the variables to the left-hand side again. So I'm going to subtract 6x from both sides. And I get 6x minus 6 greater than or equal to 1. Now I've got to add the 6 that doesn't have the variable to both sides. And oopsie, that's a little bit too high. Sorry about that. And this becomes 6x is greater than or equal to 7. Divide both sides by 6, and you get a fraction. You can leave it like that, greater than or equal to 7/6. If you want to get a decimal equivalent, I believe it's a repeating decimal, go for it. That's your choice. I'm leaving it like that. When I go to graph it, not a big deal. Here is 7/6. To the right of 7/6 is 8/6. To the left of 7/6 is 6/6. It's fine for me to keep your number line like that. It's okay. It doesn't matter that you're not simplifying 6 over 6. I'm not looking for mixed numbers. I'm looking for whole numbers. It doesn't matter. Just know that x has to be more than or equal to 7 over 6. Close circle on 7/6, and everything to the right is greater than that. All righty. Come on, switch for me. somehow we just stopped. All right, let me just pause this for a second. Okay, this does not want to cooperate. All right, so just give me a second. I need to pause and fix, and I'll be right back. All right, we're back. Let's see if this works. There we go. Okay, so the next one, distributive property. Again, it becomes negative 10 minus 12x less than 48 minus 12x. Oh my gosh, this is going to drive me crazy. Hold on, I'll try this one more time. Okay, here we go. Negative 10 minus 12x less than 48 minus 12x. I notice that the x's are the same on both sides, which means if I try to add 12x to the other opposite side, the x's are going to cancel out. What that means is you're left with this inequality, negative 10 less than 48. This is a true statement. The fact that this is true, your answer is all solutions. Ugh. The way that you would draw that on a number line is, I'm going to put some numbers on here, 0, 1, negative 1, but I'm going to shade in, or I'm going to highlight the entire number line. Okay, so the fact that we had a true statement means that it's all solutions. Let's take a look at the next one. Distribute, distribute. 3 minus 6x is greater than 3 minus 6x. Well, this is the exact same equation on both sides, which means everything is going to cancel out. So I can essentially say, all right, well, if I add 6x to both sides, I get 0. If I subtract 3 from both sides, I get 0. Let's just see what the 6x's, maybe this might be easier to see. If the 6x's cancel out, the negative 6x's, if they cancel out, like what happened on the other equation, then what you get left with is an inequality statement of 3, oh my God, of 3 is greater than 3. This is not true. 3 can never be more than itself. This is false. And because this is false, there is no solution. Which means I don't have any number line to graph. There's no solution. Let's try some of these word problems. Determine which of the following numbers in the set 18, 6, negative 3, negative 12 are in the solution of this particular inequality. Explain why you chose that value. So I'm going to look at this inequality right now and realize I've got a denominator of a 3, which means I want to clear all of my denominators. Remember, everything else is really over a 1, over a 1, over a 1. If I do math, 3 divided by 3 times 2x is 2x. 3 divided by 1 is 3 times 3 is 9. Less than 3 divided by 1 times negative 2x, negative 6x. 3 divided by 1 times 7 minus 21. If I decide to bring all the variables to the left, I get 8x plus 9 less than negative 21. Then I subtract 9 from both sides, and I get 8x is less than negative 30. When I divide both sides by 8, and I happen to be using my calculator, it turns out that x has to be less than negative 3.75. All right, so now I got to think of some numbers in this set that are less than negative 3.75. So I'm looking at this and I'm saying, okay, is 18 less than negative 3.75? And the answer is no. Is 6 less than negative 3 3/4? No. Is negative 3 less than? Well, I'm hoping that you say the answer is no, because if I were to do this and put right here, negative 3.75, this would be, let's say, negative 3. This would be negative 4. When I have an open circle and everything to the left, negative 3 is not less than negative 3.75. This is a no. This is the only one that is. So how would you explain why we chose that value? Negative 12 is the only solution because it is the only value less than negative 3 3/4. Okay, so why did you choose it? Because it's the only number to the left of negative 3.75. All right, let's look at the word problems. For each of the following, define the variable, set the algebraic inequality, solve it algebraically, and label it appropriately. Keith has $500 in his savings account at the beginning of the summer. He wants to have at least $200 in his account by the end of the summer. He withdraws. He takes out $25 each week for food, clothes, and movies. How many weeks can he withdraw money from his account so that he has at least $200 in there by the end of the summer? So X is going to be the number of weeks. So here's what's happening. Right now, he has $500 in his savings account. He spends minus $25 per week, X. He wants to have at least $200 left over. He wants more than or equal to $200 left over. That's your equation. Let's solve it. Subtract $500, subtract $500. Negative 25x is greater than or equal to negative $300. Divide both sides by negative 25. Remember, you're dividing by a negative. You must reverse your inequality symbol. What comes out is x less than or equal to, and this comes out to be an actual integer, is 12. So the answer is how many weeks can he withdraw money from his account? He can withdraw money for no more than 12 weeks. And that's going to keep the balance that he wants. So we can write this in English. We're labeling this. Keith can withdraw money for no more than 12 weeks. That's the final part of your answer. Remember, you had to set up an inequality, which we did. We had to define the variable, which we did. We had to solve it, and then we had to write an answer. Let's talk about Herman. Decides to take up golf. His golf club membership will cost him $450 for the season, and he's charged $18 for each round of golf he plays. He decides to spend no more than $1,000 on golf for the season. What's the maximum number of rounds of golf that he can play? So what's happening here is he takes up golf. His membership, so it's going to cost him $450 for his membership plus $18 per round of golf. So X equals the number of rounds. $18 per round plus the membership that he has to pay has to be in the end no more than $1,000. Well, let's subtract 450 on both sides. 18x less than or equal to 550. Divide both sides by 18. This does not come out to be an even value. It comes out to be a decimal. I don't remember if it goes out more than 2 decimal places or not, it doesn't really matter. But we're trying to find out what's the maximum number of golf rounds he can play. I can't round this thing up. I have to round it down. So Herman can play a max of 30 rounds. All of this work I'm showing you, you need to show too. You need to make sure that you define the variable. You need to make sure that you set up an algebraic equation. You need to make sure that you solve this algebraic equation. And you need to make sure that you label your answers appropriately. All of this has to be shown for full credit. 2 more to go. The length of a rectangle is 3 more than twice its width. If the perimeter of the rectangle can be no more than 78 feet, what are the possible widths of the rectangle? We've got a rectangle. We don't know anything about the width, but we know that the length is 3 more than twice the width. So x equals width 3 more than twice x equals the length. It says to you that the perimeter can be no more than 78 feet. It has to be less than or equal 78. Don't forget, perimeter means I've got 2 widths plus 2 lengths equals the perimeter, which means I'm going to have to multiply 2 times x. 2 times 3 plus 2x has to be less than or equal to 78. Essentially, you're adding up all 4 sides. However you choose to do it doesn't really matter. So 2x plus 6 plus 4x is less than or equal to 78. Combine like terms. 6x plus 6 less than or equal to 78. Subtract 6 on both sides. 6x is less than 72. Less than or equal to. Divide by 6, divide by 6. X is less than or equal to 12. And that's exactly what the width is, right? If you go back up to your let statement, it wants x to be the width. So what are the possible widths of the rectangle? Well, the widths can be anything less than or equal to 12. Now, what does that really mean? If I deal with widths being less than or equal to 12, well, I can't have a width that's 0, but I can have a width that's 1, but I can't have width that's negative. So the idea is the width, didn't ask for the maximum, and said what are the possible. The width can be less than or equal to 12, but more than 0. Essentially what has to happen, if I were to graph this, and you don't have to, but if I had to graph this thing, I'd have 0 here, I'd have 12 here. I'd say I can't be 0, I can be 12, and I could be anything in between. You're not being asked to graph it. You're just being asked to understand the possible values. 12, 10, 12, 11, 10, 9, 8, etc., all the way down to 0, but not including. So make sure that makes sense. Last but not least, sides of a triangle, consecutive integers. Remember, stuff comes back. Consecutive integers. If the perimeter of the triangle is no less than 54 centimeters, find the minimum length of the longest side of the triangle. Well, 3 sides, consecutive integers. One has to be x. The other is 1 more than that. The other is 2 more than that. So x equals first side. X plus 1 equals second side. X plus 2 equals third side. Perimeter, no less than 54 centimeters, which means if I add up all the sides, I get 3x plus 3. No less than means greater than or equal to 54. Subtract both sides by 3. 3x is greater than or equal to 51. divide by 3, x is greater than or equal to 17. If I were to go back in and plug these values, the first side could be more than or equal to 17, the second side more than or equal to 19, the third side more than or equal to 21. Find the minimum length that the longest, oh, these are, I'm sorry, this is not consecutive odds. Sorry. Let me try that again. The first side is 17, one more than that is 18, one more than that is 19. Sorry about that. So these are consecutive integers. I was going for consecutive odd. That's my fault. So then it says find the minimum length the longest side can be. Well, the minimum length of the longest side is going to have to be this guy right here. So the minimum length of the longest side is 19, I think there's a unit of measure, yeah, is 19 centimeters. Okay? Again, all the work is needed. Define the variable, set up your algebraic inequality, solve it with algebra, and then label. Okay? So that's it. So hopefully you are all set. Bye.